everyone, this video is about solving modulus equations by squaring. If we square both sides, we can ignore the modulus symbol and just expand the quadratic as usual. So we have 9x squared plus 6x plus 1 on the left. On the right we have 4x squared plus 816x plus 16, and then we can simplify the quadratics, move everything to the left. So we have 5x squared minus 10x minus 15 equals 0. We can divide by 5, and then we can factorize x minus 3x plus 1, and so we have x equals 3 or x equals minus 1, and then we check by plugging in 3 and minus 1. If we plug in 3, we get so if we plug in 3 right here, 3 times 3 plus 1, 2 times 3 plus 4. On the left we have 9 plus 1, 10. On the right we have 6 plus 4, also 10. So this is correct. And then we can check the minus 1. 3 times minus 1 plus 1. And we do the same thing for the right hand side. We have minus 3 plus 1 minus 2 in absolute value, so 2 on the left, 2 on the right. So we have two solutions then. Another example, again we square both sides and then we do the expansion and we simplify, divide, factorize. We get one solution. If you check, this is rejected. Another example, this time we have no solutions, both rejected, because as you can see, minus 4 plus 1, that's negative on the right, and it's impossible for the modulus of something to be negative. Same thing here, we plug in minus 2, we get minus 1 on the right, and the absolute value of something can never be minus 1, so again rejected. And another example, this time we have modulus functions on both sides, and we can accept the two solutions here. So this is almost exactly the same example, but as you can see we have an additional plus 3 on the right here. So this is much more complicated. If we square both sides, we can square this easily, but when we square the right hand side, we can ignore the modulus here because it is squared, but we still have modulus function here. And after expanding and simplifying, 1 plus 9 is 10, and moving everything to the left, so we isolate the term with modulus function on the right, divide by 3. As you can see, we get a quartic equation. And after we simplify, we use the rational root theorem, all the possible roots, and then we use the factor theorem, test one by one, we get all the factors or the roots. So therefore we have 1, 3, 5, 11, and then we check, and turns out we have only two solutions. So as you can see, it is too complicated if you want to use this method for this kind of question. And let's compare with our usual method. We have 4 possibilities. 2x minus 7, so this one is positive, also positive, so positive, positive, hold on, okay, positive, positive. We have here x equals 4 plus 7, 11, And now let's try positive, negative, and we have 3x equals 9, so x equals 3, and then we use a negative, so minus 2x plus 7, positive x plus 1, and now we have 3x equals 4, so 3, so x equals 1, and negative negative minus 2x plus 7 minus x minus 1, we get x equals 5. So we have 4 solutions, but then we have to check back, and if we plug in 11, 11, 11, we get on the left 22 minus 7, that's 15. On the right we have 12 plus 3, also 15, so we can use this solution. 11 is an answer. We try the 3, plug in 3, plug in 3. On the left we have 14 minus 7, which is 7, I mean 6 minus 7, so 1, and here we have 7, and 1 is not equal to 7, so we have to reject this one, so this is rejected. And the yellow solution 1, if x is 1, we get on the left 5, on the right also 5, so this one is accepted. We have another solution, and now the one in black, if the x is 5, on the left we have 3, on the right we have 6 plus 3, 8. 3 is not equal to 8, so again rejected. So we get exactly the same solution. From the squaring method we get 1 and 11, and from this method also 1 and 11, but as you can see this is much easier. So in conclusion, when solving by squaring, modulus sign gone after squaring, you can ignore the modulus sign if you square the modulus, and then you solve the quadratic equation, check the solutions. And this is not recommended actually, because as you can see it's too complicated for certain types of problems. That's it. I'll see you